yeah, they'll be recorded. The next thing we're going to talk about in terms of chemistry is how and why certain elements combine with each other to form compounds. So what did we say? What part of the atom is responsible for how something interacts with other atoms? Philip? What? No? Bella?
Nucleus?
Nope. None of our? Nope. What is like exposed to other atoms? The electrons. Specifically, which electrons? The outermost. Those valence electrons, the outermost electrons, those are what are most important when it comes to two atoms bonding together. Okay. So, I'm going to talk about this like atoms are people. Atoms don't really want anything or think anything, but it's an analogy. So all atoms want to be one thing, and that is stable. They want to have a stable shell of electrons on the outside. And so what that means for our atoms, have your periodic table out too as we do this. What that means is atoms want to have a full outer shell. Now if you look on your periodic table, look at neon, far right, group 18, or argon. How many electrons in their outermost shell? 8. Everything in group 18 has 8 in its outer shell. Everything in group 1 has 1 in its outer shell. Group 2 has 2, okay, and so forth. And those things on the far right, their outer shell of electrons is full. Typically for the outermost layer, 8 is a full shell of electrons. So what do you think that means about neon and argon? We call those the noble gases. They already have a full shell of electrons. Calvin?
They're stable.
They're stable on their own. They don't really react with any other elements, okay? Because they already have a full outer shell. All of the other elements will react to try to achieve stability. And so, look at sodium, far left, element number 11. How many electrons in its outer shell? 1. How can it become stable? By getting 7. Or, what would be easier in trying to get 7 electrons? Leah?
Getting rid of one?
Losing that outer one. If you lose that 1 electron, now the next shell inside is filled up, because that's how the electrons go. They fill up the inner layers before they start moving to the outer layers. So it can lose 1, and that's much easier, and that's typically what it does. How about oxygen? Look at oxygen. How many electrons in the outer shell?
6.
What do you think it wants to do?
Add more.
Looking to gain 2 electrons. Okay. All right. So this is called the octet rule. Atoms will form compounds to reach 8 electrons in their outermost shell, or a full outer shell of electrons. The atoms that have less than 4 electrons in their outer level, they tend to lose electrons, so that the next shell in is full. Atoms that have more than 4 electrons typically will gain electrons to fill up to get to 8. And then there are some atoms that have 4. They can either gain electrons to get to 8 or lose their outer 4 to get to the full level below.
Does that rule apply to hydrogen?
Yeah.
It's only, wait, it needs to get 8?
Nope,
No, it
because
needs to get okay.
that first shell, if you look at all of the elements, how many can it hold?
2.
Yeah, it only holds 2. That first shell, closest to the nucleus, only holds a maximum of 2, so when it's filled with 2, it's stable. All right, so this octet rule says, I think you have to go back up a slide, that atoms want to have 8 in their outermost shell, typically. And when we made our electron dot diagrams, what was the maximum number of dots we put on an element symbol?
8.
8. That's meant to help us understand how atoms will interact. So let's look at some elements here. Hydrogen, how many electrons in its outer shell?
One.
Just one. Hydrogen. Helium has 2. Hydrogen has just 1. So there's an electron dot diagram for hydrogen. They each have 1. How many does oxygen have? 6. What's it looking for? 2 more. So one oxygen atom can share electrons with 2 separate hydrogen atoms. And then the oxygen will be having how many? 8. How many does the hydrogen have? 2. And this hydrogen? 2.
So they'll all be.
Everyone's stable, right? So hydrogen each have a full shell of 2 electrons. Oxygen has 8. Everybody's happy. Sodium and chlorine, NaCl. How many electrons in sodium's outer shell?
1.
Just 1. How about chlorine?
7.
So how many sodiums do you think combine with a chlorine? Just 1. Okay, sodium gives up that electron to chlorine, and then its outer shell is filled.
What does that mean? So you're still on the same?
No, because it got rid of that one, so the next level under it
Oh.
is full. So they're both happy. Now carbon is a little weird, because how many electrons in carbon's outermost shell?
4.
4. So it could either gain 4 electrons or lose electrons. Okay. When carbon combines with oxygen, what is oxygen trying to do? Get to. So how do you think a carbon, it gives one oxygen, how many? 2 electrons. It gives the other oxygen 2 electrons. They are both full, and carbon got rid of those 4. And it's happy as well.
So is that why some elements work together?
Yep.
Okay.
So yes, that's exactly right. So we're not going to use these electron dot diagrams to figure out the formulas much. We're going to use an alternate method using what we call the oxidation number. So those outermost electrons, do you remember what we called them? Yeah, outermost shell, but there's another name. No. Calvin? Valence electrons. Okay. Valence electrons are in the outermost shell. So we look at the last number in the electron configuration. So boron has 3. Bromine has 7 in its outermost shell. So to figure out an atom's oxidation number, we look at what does it have. So boron has 3. You could think of those as it has 3 extra electrons that it would like to get rid of. So it's a positive 3 for its oxidation number. What about bromine? What does it want?
It wants 1.
It wants to get 1, so it's -1. Think of the minus sign as it's missing 1 electron to be full. Its oxidation number is a -1. And usually, positive oxidation number elements combine with negative oxidation number elements. Look at sodium. How many valence electrons?
1.
What do you think its oxidation number is?
1. Negative.
Plus
Add
1.
1.
Has 1 extra.
Yeah.
Think about the plus as extra. How about chlorine? 7 valence electrons. What do you think its oxidation number is? -1. It's missing 1 electron. If it can get it, we'll have 8.
But isn't this one missing 7?
This one, no, it's missing 1 to get to 8. It's going to do whatever's easiest.
No, the top one.
Here?
Yeah.
Nope. If it gets rid of this 1, then it will have 8 and it'll be happy. It has 1 extra electron here. If it gets rid of this 1, Anna,
Wait, so are you telling it, like, when you're writing it, that number, the oxidation number, are you telling it what to do, or
no,
like?
what it has. It has one extra. It's missing one.
Also,
Carbon has 4. It could be plus 4 or minus 4. How about gallium?
3
It has 3, so it's
plus 3.
plus 3. 3 extra electrons. We'll do a lot of practice with this next week, and then we'll figure out how these oxidation numbers combine to tell the formula when two elements.
Gallium is so amazing.
Guys,
Have you ever played